Hey, Assalamualaikum warahmatullahi wabarakatuh. Alright, in this video we will learn about the solution of triangles, in which we will learn about the sine rule, and then we will look at the cosine rule, and then we have the formula for the area of the triangle, and finally we can find the area of triangle using the Heron's formula. Alright, so let's first look at the sine rule. Suppose we have the triangle, which is something like this, right? And we have the length, which is A, B, and C, and the angles, which is opposite of A is big A, the opposite of C is C, and the opposite of B is B. Right, we have something like this, so we can actually write the, what do we call? We can actually write the sine rule, which is given by this formula. All right, so this is this formula for the sine rule. Suppose we have this triangle, right, for example. All right, how do we differentiate whether we have to use the sine rule or the cosine rule? All right, so for the cosine rule, we have something like the angle which is in between. Like, for example, you have 6, 5, and then you have the length here. And we see that the angle is actually included between 5 and 6. But for the cosine rule, the angle should not be included, something like that. All right, okay. So suppose we have something like this. All right, so we need to find theta. All right, so since we want to find theta, therefore we start with the sine of theta, all right, divided by the length, which is opposite it, which is 5. So it is equal to, all right, so let's look at another side which has this angle 80, and we have sine of 80, sine of angle. After sine should be followed by the angle and divided by its length, which is opposite it, which is 9. In this case, we got sine theta, which is actually given by sine of 80 divided by 9 multiplied with 5. All right, pressing our calculator, so sine of 80 divided by 9 multiplied with 5, I've got this one as 0.5471. Therefore, I want to find theta, which is given by sine inverse of this 0.5471. Therefore, I've got theta, which is given by 33, right, 0.17 degrees. All right, 33.17 degrees. All right, so now suppose we have, like, for example, this triangle. All right, so we see that the what do we call, the angle is not the length 10 is not included there. No. All right, so it seems like, all right, so I want to find x, therefore I start with x. All right, so x over sine, which is of the angle which is opposite it, which is sine of 65. And then we have the length, right? If you start with length, therefore you have to put length at the numerator. Therefore you have 10 over sine of 70. All right. Therefore you can directly find the x, which is given by 10 over sine of 70 multiplied with sine of 65. All right. Therefore you have 10 divided by sine of 70 multiplied with sine of 65. I've got x, which is given by 9.645 centimeter. All right, or it can be written as 9.64 centimeter. All right, something like this. So that is my length. All right, I've obtained this using the sine rule. That's how you use sine rule for finding either the angle or the length. Suppose you want to use the cosine rule. So what is the condition that you have to know? When do you need to use the cosine rule? When you have something like this, like, for example, all right, the angle 30 here is actually included between 7 and 9. It is between here. All right, and then you have the length which is opposite it, all right, which is x. So in this case, all right, if you want to find x using the cosine rule, in this case, this is actually x, and A is actually 7, and B is actually 9. A and B should be the angle that makes the the length that makes the angle included between them. All right, so C should be 30 degrees. All right, so substituting this, we have x squared, which is given by 7 squared plus 9 squared, which is minus 2 of 7 multiplied with 9 multiplied with cos of 30. All right, therefore I've gained this one as, all right, 7 squared plus 9 squared minus 2, 7, and 9 cos of, what do we call it? Cos of 30. All right, therefore I've got this one as, all right, 20.88, and I want to find the square root of 8 because I want to find the value of x, not x squared. Therefore, I've got x, which is given by 4.57 unit. In this case, unit, we don't have centimeter. All right, so 4.57 unit. All right, another way, another example that can use the cosine rule is the angle. Suppose the angle, which is, you look at this, right? So the angle is obviously between 6 and 5, and it is included here. All right, so we have the length, which is opposite the angle, which is 4. Therefore, we have, like for example, in this case, we know that this is the x, c, right? So, right, you start with c squared equal to a squared plus b squared minus 2 of ab cos of theta. In this case, you want to find theta, where c is actually 4 and a is actually 6 and b could be 5. All right, therefore we substituting this, therefore we got 4 squared, which is given by 6 squared, plus 5 squared minus 2, 6, 5 cos of theta. And our aim is to find the cos of theta. In this case, we need to simplify this one. 16, that one is 36, this one is 25, which is minus 60 cos of theta. In this case, I want to have the term with the cos theta to be brought to the left side. Therefore, I'm going to change the position between these negative 60 cos theta and 16, bring it to here. Therefore, I have 60 cos of theta, which is given by 61 minus 16. All right, so I simplify this one. 61 minus 16, I've obtained as 45. Therefore, this one is actually 60 cos of theta, which is given by 45. And I want to find cos of theta, which is given by 45 over 60, which is given by 3 over 4. And to find theta, I need to use cos inverse of 3 over 4. Therefore, I've got, all right, this angle as 41.41 degrees. All right, so 41.41 degrees. So that's my theta in this case, right? So that's how you use the cosine rule to find the either length or the angle. So let's now look at the area. All right, so to find the area, you have to use the formula which is given by this half AB sine C, with one condition that A and B must make the angle theta, the length A and B must make the angle theta included between them. So meaning to say that the angle that we're going to find the sine should be in between A and B, all right? So the C should be included inside. All right, therefore in this case, like for example, we have this example. So we see that 85 degrees is actually between 3 and 5.5. Therefore, we can directly use the formula for the area, which is given by half. A can be 3, B can be 5.5, and C, sine of C should be sine of 85 degrees. And then we can find the area for this one, which is 3 over 2 multiplied with 5.5 multiplied with sine 85. Therefore, I've obtained the area, which is given by 8.22 centimeter square. All right, so that's the answer for this one, 8.22 centimeter square, directly from this formula of the area. All right, so another way of finding the area, we can use the Heron's formula. But when can we use the Heron's formula? When we don't have the angle, like for example, we don't know the angle here. Therefore, we have to use the Heron's formula, in which we must know the length, which is given by A, B, and C. So all sides of the triangle should be known before we can use the Heron's formula. So to find the Heron's formula, the first thing that we have to do is to find the value of S, which is given by half of the summation of A, B, and C. All right, we have to sum all the sides and we divide by 2, and then we can find the area by using this formula. All right, to illustrate this formula, let's look at this example. All right, suppose we have these 3 length, 3, 4, and 5.2. Of course, we have to find it S first. So S should be half of the 3 plus 4 plus 5.2. And I've got my 3, 4 plus 5.2 divided by 2 should be 6.1. So my S is now 6.1. So to find the value for the area, we must use the formula, which is given by S, which is 6.1. And then S minus A, 6.1 minus 3. And then we have 6.1 minus 4. And I've got 6.1 minus 5.2. and we should find the square root of this. All right, so simplifying the one in the square root first. So 6.1 multiplied with 3.1 multiplied with 2.1, and also 6.1 minus 5.2. I've got 0.9. All right, so that's it. All right, now we can actually find the what do we call multiplication of 6.1 multiplied with 3.1 multiplied with 2.1 and 0.9, and I find the square root. All right, so this one is actually the square root of, all right, square root of 35.7399. Therefore I've obtained its square root as 5.98 centimeter square. So meaning to say that the area is given by 5.98 centimeter square. All right, okay, so that's it. That's basically how to use the Heron's formula. So now let's look at this example one. All right, suppose we need to find theta. So which rule should we use? All right, so in this case it is obviously that theta is not included by any length which is between this and this one. We don't have these two lengths, all right, but we have only 40 centimeter there, so we cannot use the cosine rule. So obviously we can use the sine rule. So to find theta, of course we should start with sine of theta divided with the length which is opposite it, which is 18, which is equal to, all right, if you start with angle, therefore you start with sine of angle, so 50, you should divide with the length which is opposite it, so it's now actually 40. Therefore I can find sine of theta, which is given by sine of 50 divided by 40 multiplied by 18. All right, so pressing our calculator, so minus 40 multiplied by, sorry, divide that out. So I've got this theta which is given by, sorry, minus 40 multiplied 18. I've got 0.3447. So to find theta, I've got to find the sine inverse of this one, 0.3447. So I've got sine inverse of the answer from the calculator. I've got the theta which is given by 20.16 degrees. Right, so theta is an angle, should be in degrees in this case. So we need to find the value for AC. All right, so let me just delete this one first. All right, so what we are going to find is actually the AC in this case. All right, so if you need to redraw, then just redraw this one. You've got 40, 18. All right, since you have already had the value which is given by, what do we call this one, what do we call theta, which is 20.16. all right, therefore you can actually find the angle for ABC. You must show the working to find the angle of ABC. How do you find the angle of ABC? So because in a triangle you already have the what do we call 180 degrees, which is interior angles, minus 50, and then you minus 20.16. Therefore I've got, okay, 180 minus 50 minus 20.16. This one is ABC, which is given by 109.84 degrees. So this is actually 109.84 degrees. All right, so there are many ways of doing this. It's either you want to find this using this AC, this is AC, using sine rule, all right, or you can also use cosine rule, so it's up to you. In this case maybe it's easier to use this sine rule, so just consider this one as 50. All right, so let me just consider that one. So I've start with the AC, the length of AC. I've divided with the sine of the angle opposite it. All right, so of course this one, so sine of 109.84 degrees. This is equal to, all right, well, let's look at another one. So we have 40, and its opposite is actually sine of the 50, in this case 50. All right, so to find AC, we can directly get 40 divided by sine of 50 multiplied with sine of 109.84 degrees. All right, so 40 divided by the sine of 50 multiplied with sine of 109.84. Therefore I've got the length for AC, which is given by 49.12 centimeter. 49.12 centimeter. You can try using the cosine rule. All right, so you should obtain the same answer, I guess. Find the area of the ABC. All right, so that is very easy. You already have this triangle. Basically, you have 18 here, and here is actually 40. You already found the angle, which is 109.84. Therefore, it is obvious that you can find the area using the formula, which is half AB sine of C. In this case, all right, half of the A is actually 18 and B is actually 40, and sine of 109.84 degrees. So I've got my answer as 9/40 sine 109.84. The area in this case, which is given by what do we call 338.63. all right. But let me just check with the other side. I guess we cannot use that one. Let me just check. Half multiply with 18 multiply with 49.12, sine of 50. Yes, we already got the answer as that one. 9 multiplied 40 multiplied with sine of 109.84. This one has 338.63 centimeter square. Right, that's the area. You can try this using Heron's formula, right, in which you consider the length of all sides of this triangle and you get the answer for the area. It should be of the same answer. Alright, so let's look at example 2 here. Suppose we need to find the angle theta. We look at this and we see that the theta is actually included between 5 and 6 when we have the, obviously we have the length which is opposite of the theta. So we must use the cosine rule. In this case, right, so we start with the, like for example, c squared, which is given by a squared plus b squared minus 2ab sine of c. In this case, c, small c is here, is actually 10.28 square. A is the and the length that make the theta included, therefore 5 square plus 6 square minus 2ab 5 6 8 sine of theta. So we are going to find theta in this case. All right, this big C. Therefore we have to simplify this one. 10.28 square, which is given by that one, should be 61 minus 60 sine of theta. All right, therefore I'm going to bring the negative sine of theta to the right side, to the left side. All right, so I've got 60 sine of theta. This one is given by 61 minus 10.28 square. All right, when you press your calculator, 61 minus 10.28 square, you should get negative of 44.6784. all right, so this one is 60 sine of theta. So sine of theta should be given by, so you have to bring 60 to the left side, to the right side. Therefore I've got the sine of theta, which is given by negative 0.74464. But what we need to do is to find the area, right, of the sine where it is actually a negative. So ASTC, all right, so ASTC, so sine is actually all right, there's something wrong here. It should not be sine because the name is cosine, right? Cosine rule. So this one is cosine. Sorry, my mistake. All right, sorry, my mistake. So it's cosine, 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 and cosine. Where is the area where the cos is negative? So of course on this sides and this sides. So this is the basic angle. So you have to find the basic angle first. The basic angle is given by cos inverse of 0.74464. So cos inverse of 0.74464. I've got the basic angle, which is given by 41.87 degrees. But which one should the theta be? So it should be from this to this one. All right, because obviously logically theta is something which is greater than 90 but less than 180 degrees. Therefore in this case, theta, which is given by 100, what do we call that one, 180 minus 41.87 degrees. So 180 minus 41.87. So I've got this as 138.13 degrees. So that is my theta. Next, we need to find the area of ABC. You can actually find the area of ABC using the very easy, using the half AB sine C, but in this case I want to show you an alternative answer. So what I do is to find this using Heron's formula. To find this using Heron's formula, you have to firstly find the value for S, which is given by half of the summation of 5, 6 and 10.28. all right, so when I get this 5, 6 and 10.28 divided by 2, this one is given by 10.64. So next one is to find the area using the formula for the Heron's formula, which is 10.64. 10.64 minus 5, 10.64 minus 6, and 10.64 minus 10.28. Therefore, right, we can simplify the one in the square root. 10.64, and then we have 5.64, and then we have 4.64. that one should be 4, right, not 5. 10.64. all right, and then I have 0.36 in this case. All right, so let me just multiply the one in the bracket first. 5.64, 4.64 and 0.36. I've got that one as 100 point something, so I can directly find the square root. So this is given by 10.01. I've got 10.01. if you use your half AB sine C, therefore I've got 5 multiplied with 3 multiplied with sine of 138.13. yes, I've got the 10.01. Suppose you want to check your answer whether you use Heron's formula correctly or not. You can try the half of AB sine C. In this case, A, B, 5, 6, and you find the sine of 138.13, and then you actually get the same answer, which is 10.01 centimeter squared. You should try on your own, right? If you don't believe me, right? So this one should be cm squared. So we're done with example number 2. All right, let's look at this one. All right, suppose we have this. Okay, given the area of the triangle is 9 square root 6, find the side of each side, meaning to say that we have to find 4x, 5x and 7x. We already have the area, right? Since we have the area and we have the length of all sides, so we have to use the Heron's formula. In this case, all right, so it is the Heron's formula is in terms of x. So x is half of the 4x plus with 5x plus with 7x. Therefore, I've got this one, all right, so 4 plus 5 plus 7. Half of the 16x will give me 8x. So that is my s. So now, the area for the triangle, which is given by this, all right, area which is given by, so ss minus a, all right, let me just write the formula first, s minus b and s minus c. So in this case, all right, something like this, s is actually 8x, so we have s minus a, which is given by 8x minus 4x, and then I have 8x minus 5x, and then I have 8x minus 7x. all right, so you find this, simplify, all right, so we get this 8x, this one as 4x, this one as 3x, and that one as x. All right, so we need to multiply, so 4 multiplied by 8 multiplied by 3, therefore I've got 96. Square root of 96x to the power of 4. All right, we try to simplify this. All right, so we know that the area is given by 9 square root of 6. Okay, so what should we do is to multiply the, not multiply, take square on both sides. Therefore I take square here. When I take that square, I've got 9 square multiplied by 6. So this one should be given by 96x to the power of 4. 9 squared multiplied by 6, I've got 486 equal to 96x to the power of 4. Therefore, x to the power of 4 should be given by that one, 486 divided by 96. Alright, I've got 5.0625. Therefore, when I want to find the value for x, basically it should be plus minus, but since it is about the length, right, so I have to take the 5, alright, 0.0625 here, alright, root 4, alright, so we have answer, alright, so x, which is given by 1.5, alright, x is given by 1.5, plus minus, but x is 1.5 only. Why? We do not consider the negative part of the length in this case. So therefore, to find each side AB, which is given by 4 multiplied by 1.5, you get the answer. BC, you multiply 5 with 1.5, you get the answer. And finally, you can find AC, which is given by 7 multiplied by 1.5, and you get the answer. Alright, I'm not going to show the full solution here. Alright, let's look at the last one here. In this case, alright, you can actually find the area of, okay, you need to find the area of ABCD. Actually, right, so this is quite tricky. Alright, so what you can do is actually to find the length of BC first. Alright, so try to find the length of BC. Alright, so how to find the length of BC? So in this case, to find the length of BC, of course, alright, so you have to find it using the cosine rule. So let's look at the cosine rule. So we have BC squared, which is given by, alright, so these 3.7 and 4.6 square must add together. So 3.7 square plus 4.6 square minus 2, 3.7, 4.6 cos, yeah, remember cos of 48. Therefore, simplifying this one, alright, so I've got, let me just calculate first. Minus 2, 3.7, 4.6 cos of 48. I've got that one as 12.07. Therefore, to find BC, I have to find the square root of BC. Is actually given by 3.475. Let's say you assume that BC is actually 3.475. Alright, so let me just write the information. Once we've got the information, we just write it down here, right, to 3.475. Alright, so actually when you already have that value, you can actually find the length here. Okay, the idea is to find this, right? We already have 4.6, and the summation of this one should be, alright, so 3.475 plus with 3.5, right, so 6.975. so how do I got this? Alright, so from A to C, so AC, which is given by 3.5 plus with 3.475, which is given by 6.975. So I just need to find an angle there so that I can find the area using half AB sine C. But to find the angle here, so you have to use the sine rule. Suppose we have the angle here is theta. So firstly, we find the sine of theta divided with the opposite of it should be, 3.7. Let's try 3.7. And then this one should be given by a sine of 48 divided by 3.475. Therefore, alright, sine of 48 divided by 3.475 multiplied with 3.7. Alright, so I've got sine of theta, which is given by, say, 0.791. So to find theta, I need to find the sine inverse of this one. Therefore, sine inverse of this one should be given by theta is actually 52.30 degrees. So that is angle theta, 52.30 degrees. So now you can find the area of the triangle. So area of the triangle, which is half AB sine C. This is A and this is B. 4.6 and 6.975 multiplied with sine of the 52.30 degrees. Therefore, alright, so 4.6 divided by 2, I've multiplied with 6.975 multiplied with sine of 52.3. I've got the area, which is actually 12.69 centimeter square. Alright, so we are done with finding this area. Alright, so that's it. I hope you have enjoyed watching this video. Thank you, and I wish you all the best. Good luck.